So what do I, as a mentor, actually do? If you can, take some time to sit down with your child to introduce a new or troublesome fact to learn. This may be one that has arisen through using the Tables Logik practice app. You may choose to use counters, tens frames, pencil and paper. Any form of counters will do, for example bottle tops or pebbles. You can make a tens frame out of paper or card and draw circles using a pencil around a plastic milk bottle top, for example. Exploring a number fact. The multiplication of two numbers can always be interpreted in two different ways, but the product is the same, so learners should be encouraged to calculate the answer in the way they find the easiest. Two different ways of writing the fact are always shown in the app. Discussing the illustration of a number fact with learners helps them arrive at what makes best sense for them to remember. For example, 5 2s and 2 5s can both be made with counters, and the learner can decide which is the easiest for them to remember that the product of both 2 and 5 is 10. The best way is their way. Once you've arranged the counters to represent the fact to be learned, and the learner has had opportunity to find different ways to explain why the fact is true, the learner needs to choose the way they want to use to remember. You can do this together, but be careful not to take over and force your preferred method. The important aspect here is that the learner themselves choose the way they feel the most comfortable with to explain the answer, and so use this to remember, at least to begin with. After practice, they will begin to answer automatically and fluently. Let's look at an example. Ask the learners to arrange the counters into groups that illustrate the number sentence. Encourage them to use the tens frame if they wish. Depending on which version they choose, 7 3s or 3 7s, point out, "That's great, you've chosen to do 7 3s. Can we make 3 7s with exactly the same number of counters?" Encourage the learner to move the counters around to prove they use the same number. You can, of course, choose to arrange the counters in a rectangular array. This shows 7 3s or 3 7s. Depending on where the learner is, this may not be deemed necessary if they already confidently understand cumulativity. So how many altogether in 3 7s? Look at the chosen arrangement. Encourage the learner to move the counters to show how many counters there are in total. Pose the question, how many ways can we prove that 3 7s is 21? For each method, encourage the learner to explain their method in words as well as showing their explanation practically using tens frame and the counters. So what ways could they suggest? I can see 3 7s as 3 5s and 3 2s, which is 15 and 6. Together that makes 21. 7 is 3 less than 10, so 3 7s would be 3 10s less 3 3s, which is 21. I know 2 7s are 14, so another 7, which is 6 and 1, makes 21. Ask which is their favourite method. Ask the learner to choose the method they want to use to help them remember. Ask them to imagine the counters in their chosen method and get them to explain without using counters but only their memory.